Okay, 1.9 inverse functions. So you guys needed your composite functions to be able to do inverse functions. We are going to verify and find inverse functions. That's what we're doing. So we first have to talk about inverses. When a function is an inverse, the domain of one is the range of the other, and the range of one is the domain of the other. So the domain and range physically switch places. Domain is x, range is y. Yes? They physically switch places. So when I verify if they are inverses of each other, I take f inverse, and when I do that composition, my answer will be x every single time. And then when I do f inverse of f, my answer will be x every single time. If they are inverses of each other. If I get negative x, then they're not inverses. The negative one, like f to the negative 1 means inverse. And you have to do both. When I say verify their inverses, you have to do f inverse and f inverse of f. You have to do both. What are you thinking, Carson?
I couldn't tell the difference.
You got it now? You see it now? Okay. I could tell you were thinking. That's why I was asking. Am I good?
Yes.
Okay. Okay, so which function is an inverse of f of x equals x over, 5 over x minus 2? So either g or h is an inverse of that. So what I have to do is I have to do g of h of x, h of g of x, and they would both have to equal x, or it's going to be f of h of x, h of f of x would have to be equal x. So one of those two groups. So which one do you guys want to try first, G or H? G? Okay. So G of H of X. So that means I'm going to put, I put an H and this should be an F. I apologize. It should be an F and I put it, and it should be an F and I put an H. Okay, so I'm going to put this H in for that X, correct? So that gives me 5 over X minus 2 all over 5. So I have to get common denominators. So this is 2 over 1. So I have to multiply by x minus 2. Yeah. So I get 5 minus 2x plus 4 over x minus 2. And that's going to be all times 1/5, isn't it? Mm-hmm. Okay, well, let's see. 5 and 4 is 9. So I have 9 minus 2x over 5x minus 2. Is that going to reduce all the way down to x? No, it's not, is it? Now, I said both g of f and f of g had to equal x. So is there any point in doing the other one? No. The first way doesn't work. There's no point in going to the second. Now, if we go to h and it doesn't work either, then we better go check our work. Correct? Are you guys good with saying that didn't work right now? Let's go to H. Yeah. Okay. So if I'm going to do f of h, so I'm going to put I'm going to put h into f, right? Because I wrote it different. Yep. So f of h of x. So that's going to give me 5 over x, but the x is now this whole thing. So 5 over x plus 2 minus 2. Okay. So 2 minus 2 is 0, yes? And then I multiply by the reciprocal, so x over 5, which gives me just what?
X.
X. Do you see how easily, like it looked bad, but did it fall apart pretty easily? Like it simplified down? So now I have to do h of f of x. So now I'm going to put f in for this x, correct? So 5 over 5 over x minus 2 plus 2. Now, when you have something like that, worry about the left-hand thing first. Okay, don't try to get common denominators with that. That would be gross. So I would multiply by the reciprocal of 5 over x minus 2. So I have 5 times x minus 2 over 5 plus 2. So the 5's reduced to 1, don't they?
Yep.
And then I have x minus 2 plus 2. So I get x. Okay? So h of x is equal to f inverse of x. Oh, that's not a prime. It's a negative 1. Sorry. So inverse is the negative 1. Now, everyone gets upset with me when I say, in this case, it says the inverse and not the reciprocal function. But the inverse of x is 1 over x, which is the reciprocal. This is the negative exponent is on the function, not like a number. Does that make sense what I'm saying? Yeah. The difference between those two things. So in order to verify that if it's an inverse, you have to do f of g of x and g of f of x, and it has to equal x. Now, if it's t, then it equals t. If it's w, it equals w, the variable. Okay? Think I have one more. Okay, so show that f and g are inverse functions algebraically and graphically. And we'll talk about the graphically in a second. So I need to do f of g and g of f. So f of g of x and g of f of x. I will let you guys do that. And you have to do both. Did you get it? That was an easy one, wasn't it? Okay. So verify, show that, prove. That's how you do it. Now, do you guys remember what the graphs look like when we they reflect across? Okay, so we have the XY line that looks like this. Yes? And they reflect across those two lines. Across this, but these are linear. Both of these are linear, correct? So this one goes through 1, 2, 3, 4, 5. So it looks like this. And this one goes through 1, 2, 3, 4, 5. So it looks like this. And are they reflected across that line? Yeah. Yes. Now we have ones that will go. Here's the XY line. Let's see if I can do it. It'll be like this. So the other one would be like that. Kind of. Make sense? Yeah. You can put them in your calculator to see that. Okay. So if it says check graphically, you can put it in your calculator to see. I don't have a problem with it. Okay. Does the function have an inverse? Every function has an inverse. The real question is the function's inverse also a function? That's the real function. Because when you first learn about inverses, they usually say yes or no. They don't have one. Well, they have an inverse. They may not have an inverse function. Okay? So the answer is yes if the function, if it is a function, first of all, so it passes the vertical line test, every x has 1y. Does it pass the horizontal line test? Remember we're talking about a 1-to-1 relationship? Okay, so that means I passed the horizontal line test, meaning every y has 1x. So if an equation passes both the vertical and horizontal line tests, then it is called a 1-to-1 function. You need to know that a 1-to-1 function means, right here, every domain x value has exactly one range y value, and every range value has exactly one y value. And you can say every x has exactly one y, and every y has exactly one x. But you need to know what 1-to-1 means. Okay? Am I good? Nobody's writing this down? Okay. So, are these functions, are these two functions? Do they pass the vertical line test?
Yes. No.
Vertical line test. Do they pass the vertical line test? Yes. Yes?
I second guess myself, yes.
Okay, so they pass the vertical line test. So, do they have inverse functions?
Oh,
So, do they pass the horizontal line test?
no. Not
No and
Yes.
yes. So, x cubed minus 1 is a 1-to-1 function, meaning its inverse is also a function. So, if I reflected this graph, let me get a line. Across that line. See if I can do it. It would look like that, or something like that. Make sense?
Yeah.
Okay. Okay, finding inverses graphically, you just interchange what two things?
X and Y.
X and Y. If I give you a graph and say, make me a graph of its inverse, every single point there, the X and the Y are just interchanged. Correct? We're good there? Okay. That's an example of one. Mine were better, way better, weren't they?
Oh.
What's their face?
Do you see how it's reflected across that XY
Yeah,
line?
yeah.
Now, they're showing it's touching. Do they always touch? No. But if they do, where do they touch? On that XY line. Because when you interchange 3, 3, you get what? 3, 3. And that's what's going to happen. Isn't every single point on this line 1, 1, 2, 2, 3, 3? Yeah. Okay? So if they are going to touch, it's going to be on that XY line. Okay, finding the inverse. First, you need these steps. To find an inverse, you need to interchange the x and the y values. Do you need a Band-Aid? Okay. So, first thing you need is interchange the x and y values. And then you need to solve for y. And then I'm going to tell you, you always check, and guess what you're never going to do unless it tells you to? Check. You guys remember doing this at all last year?
Yeah, I do a little bit.
No, it doesn't.
All we are is doing the same stuff from last year.
Yeah, first semester is all last year.
Should bring mine back now in 2 minutes. Did you say we were gonna need those?
I told you not to get rid of them.
When I don't remember.
Okay.
I have them.
You don't have to bring them with you. I'm just saying, legitimately all last year is this first semester. That's one thing I do like about the Algebra 2 book, but I think they like put you in the deep end. It's like teaching somebody to swim by throwing them into 12-foot water.
You too.
That's how I learned how to swim.
That's how you learned Algebra 2 too.
Yeah.
I didn't learn how to swim. I was never thrown into a lake.
I was.
You guys good? Okay. So, find the inverse. So what's the first step? Okay, so there's no y there.
It's yours.
Yes, there is. Where is it?
It's
F of x. So I'm going to make it x equals 7y plus 4. Then I do what?
Solve for y.
Solve for y. How do I solve for y?
Subtract 4 divided by 7.
Subtract 4, divide by 7. So y equals x minus 4 over 7.
Yeah.
Would you guys like to verify so we can do it one more time? Are we good?
We're good.
Everyone good with that? Lily, you good?
No, that's Carson. I'm good.
Okay.
Did it.
Noah, are you keeping track of how many slides I've gone through?
No, I think you got like 2 more.
Okay.
You told Noah how much.
He asked. Okay, find the inverses. You guys try it.
These two are weird.
No, they're not.
Oh.
What do we do first, Carson?
Carson's trying to
Mul- uh, multiply by 2.
Multiply by 2. Always get rid of that denominator, right?
Carson's you little goober.
Carson, you dropped a piece of paper.
Yeah.
Okay. So you should get 2x minus 5 over 3. Yes? I can't convince you. What'd you get?
Wait, wouldn't that be negative 3 or would that have that be positive?
Yeah, I was about to ask that.
Oh.
Where did it go?
It disappeared.
Okay.
And I just, okay. And I personally don't like the negative down there. So what I do is I distribute it through the numerator. So I think your book does also. So is this the same answer?
Yeah.
Yep. You see that, Carson?
Yeah.
Okay. Now, I know some people will write it like this. I think that's worse than putting the negative 3 in the denominator. Just take one of them. I have 2. Okay. Do the next one.
This one's easy.
What's the answer then, off the top of your head?
It's not roll off the top of my head. Oh, it's not very hard.
Thanks.
Not
all
I
of
really
us.
don't know how to find much.
Can't wait until I can bully that kid.
Lily, what do I do first? How do you get rid of square root?
Square.
Square it. So I square both sides.
Oh, I didn't even write it.
Well, that usually helps.
I know. That's my bad.
And now we're just going to do what? Say it. Noah, what are we going to do?
What?
What are we going to do now?
Y equals 3 plus, x squared plus 3 over 2.
So we're going to add the 3 divided by 2.
Those are talking. I'm good.
Okay, so Really, the first step after you interchange the x and y is the only like hard one, right? So you have to do, guys, you have to do the inverse operation. What's the inverse of division? Multiplication. Is that the first thing we did?
Yeah.
Yes. What's the inverse of a square root? Squaring. Okay. I think that's it. Oh, no, there's more.
I've had this for years.
Okay.
This is the last one.
This is the last one. Yep. Okay. I'm just giving you the hard ones. Let's go, Carson. Let's go. They're not hard.
I have a permit for this.
Okay.
I have a permit for this.
Okay, let's do it. Then do it. If you got a permit.
Yeah, Mr. Permit.
No.
Okay, I'm recording. Let's go.
Because if you do it for city in general.
What do you think we do? So if you square to get rid of a square root, what would you do to get rid of a cube root? Cube it. So x cubed
Yep.
equals 10 plus y. So I'm pretty sure y equals x
Oh, wow,
cubed
looked like an eggs.
minus 10. Well, you
That's
better
what I got.
get better at it. Okay, next.
I'll do
X equals, ooh, what's the problem now?
It's there's a y equals or y negative y minus 3 over y plus 2.
Right. But again, I said, what is the inverse operation of division?
Multiplication.
Multiplication. So what's the first thing I have to do?
Multiply.
Multiply. So I have x times y plus 2
Yeah,
equals y minus 3.
yeah.
Okay.
You're just saying yeah.
No, I did that. I already have that.
Okay.
I got it.
So what's the math tell me to do now?
Distribute.
Distribute the x. So I have
And you
x,
have x, y.
y plus 2 equals y minus 3.
Well, 2x.
Oh, 2x. Thank you.
Yeah.
Okay. So what am I solving for?
Y.
So what do I need to do to solve for something?
Add 3.
Get them all on one side, yes? So you want to move the y's to the left or to the right?
I mean,
We're solving it. I would move them left.
left.
It's left? Okay, so I have x, y minus y equals negative 2x minus 3. I had to move the x to the right.
Yep.
Okay. Now I have 2 y's. I want 1 y. Looking at the left, what could I possibly do with that?
Subtract.
Not subtract. Can't. Do not like terms. Can I factor a y out?
Sure.
Is that how to get from 2 y's to 1 y? Is that how I went from 1x to 2 x's?
Yeah.
Yes. Right here.
Huh. Huh.
So I have y times x minus 1 equals negative 2x minus 3. And then divide. So y equals negative 2x minus 3 over x minus 1.
Okay.
Now, let's look at that again. Okay, so you guys knew that we had to multiply immediately, yes?
Yeah.
Okay, so then we had to distribute because we're trying to solve for y, so we got to get out of the quantity, don't we? Right here?
Yep.
So we had to distribute. Then we moved the y's to one side, everything else to the other. So why did we factor? Why did we do this?
Yeah. 1 y.
To get 1 y. And then I just divided over. Okay? Are we good?
Yeah.
Okay. So that's all I got for you today.